All right, guys, so this is part B of section 8.4. Okay, this is all still for April 14th. The last problem we did was problem 4. I wanted to make sure that I should have really written the ratio test, though I think it's pretty obvious. You know, if I can clearly tell what you use, that's okay. And then I just wanted to show you kind of like down here real quick, like what happens if you tried to do the alternating series. It does actually work. Remember, the alternating series is where you ignore this. Oh, maybe I should back up. I changed this 2 to the n, or negative 2 to the n, sorry, negative 2 to the n. I changed it to negative 1 to the n times 2 to the n. So you can do that. And then the alternating series says you just take this, right? We'd have to maybe test to see if it got smaller and smaller. That might have given it away, I think. Maybe I should have done that. I was thinking, though, if I took the limit, it would get a little dicey because I'd have to do, it's infinity over infinity. I'd have to do L'Hopital's rule. The derivative of this, I don't know if we remember that. That is 2 to the n ln 2. And then this would be 2n. And then we'd have to do it again. But it's possible. It does actually work out. You have to do it one more time. I think maybe if you plug numbers in and you saw that it wasn't always decreasing, then it does diverge. So it's an option. And that's kind of maybe the hard thing, maybe the good thing. Like, more than one test will work. So I'll kind of just point out, sometimes I'll try to point out more than one. And then sometimes the bad thing is, though, sometimes they lead you down a wrong path. We're going to do one of those towards the end, if I can figure out where I wrote it. Okay, I wrote it there. All right. Okay, so let's look at 5, though. Okay, so problem 5. I'll just put it here. Remember, oh, shoot, I should have wrote the directions. I should have wrote the directions. What are the directions? We're seeing, is it absolutely convergent, conditionally convergent, or divergent? Okay. All right, so let's take a look. N equals 2 to infinity, negative 1 to the n over ln of 3n. Okay, so this I said, it is an alternating series. And I said, hey, if I pull that out, it's not too bad to look at. It's pretty straightforward. I do have that log no matter what. And I think what I was thinking is, I don't know if I really want to do the log in the ratio test, because that could get a little messy. So I said, hey, why don't I do the alternating series test? Okay, this, if anything, this is kind of set up for the alternating series test. And I think if we would have done the ratio, we could maybe take a look at that. Sometimes, though, you just kind of you just have to try some different things. We'll see. If I have time, maybe we'll go back and see it, if we could do something with the ratio test. Okay, so what is the alternating series? Let's go back to that. Remember, the alternating series says, let's just look at this. Does it get smaller and smaller? N equals 1. Should I bring it over here? Remember, we want, if we write it the correct way, right? We want each one to get smaller and smaller. So 1 over ln of 3, because I'd plug in a 1. 1 over ln, I plug in a 2, I get 6. I plug in a 3, I get ln of 9. I plug in a 4, I get ln of 12. Okay. And then I just grabbed my calculator and I did the whole thing. So I didn't do ln of 3. I literally did 1 divided by ln of 3. But you could even see, like, remember, as the bottom gets bigger, the overall fraction is getting smaller. That might be good enough. Otherwise, where did I have the numbers? I got like 0.558. Remember, that's typing in literally the whole thing. Oh, shoot. Actually, get rid of this guy. Technically, that's wrong. Technically, I shouldn't have done 1, even though it works. Why shouldn't I have done 1? Is because we were technically supposed to start at 2. All right, so we can toss that guy. Sorry about that. So this guy is 5.558. 1 divided by ln of 9, 0.455. This guy, I don't know. Yeah, this guy's 0.4 something. So you can see that they're getting smaller. Okay, which is good. So that's I. That's good. All right, so now double I says we officially take the limit as n approaches infinity. And again, I just focus in on this guy. Okay. And exactly kind of what we were saying here. The bottom is going to get bigger, or the bottom is going to get bigger and bigger and bigger. Yeah, just, you know, put in 100, put in 1,000. ln, it takes a while to get bigger, but if I want it bigger, I just put in a bigger n value. So as the bottom gets bigger, the overall fraction is headed towards 0. Okay, which is beautiful. The limit has to equal 0, then it is convergent. Here's the problem. Okay, so this converges. Okay, but absolutely converges, okay, or conditionally converges. Okay, so here we have to decide which one this is. Is it absolutely convergent or conditionally convergent? Because both of these, the alternating series converges. So how do I decide which one? I have to look at just the positive series. So now I have to look, and it's kind of weird, I have to look at just this guy. The limit as n approaches, and well, we could even write it like this. I have to look at just this guy, 2 to infinity, of just the positive, 1 over ln of 3n. Okay. Let me write that bigger. The summation n equals 2 to infinity, 1 over ln of 3n. Now I have to see, what does this happen? What happens here? Converge for alternating, if they converge, it's either absolutely or conditionally. How do I decide which one? I have to take a look at just the positive series. Okay, I have to take a look at just the positive series. So I have to take a look at this. Now, you could say, hey, didn't I do that right here? But when I take a look at right here, if I'm just looking at the positive series, I technically did the test for divergence. Let me see if I have that. That's the first one we did, right? The test for divergence. I technically up here did the test for divergence, but if it doesn't equal 0, then I know it diverges. If it equals 0, I don't know what it is. Okay, so we don't want to do the limit. I mean, we could do the limit. It's actually a good test to do, but because here it doesn't make it, okay? The test for divergence doesn't work here. So I got to now just look just at this and try to figure out, does this diverge or does this converge? Now I'm looking at just the positive series. Okay, I have to focus in just on the positive series. So I know that the test divergence fails. Okay, so now I got to think of something else. I am going to do the comparison test. I forgot what it was called. The comparison test. Okay, so I need a benchmark. Remember this stuff? So that's the problem with the alternating series. With the alternating series test, if it converges, you have to do a whole nother test to see if it absolutely converges or conditionally converges. Okay, that's the only issue with the alternating test. If I just had to say converges or diverges, I'm done and I move on. But if they want it, is it absolutely or conditionally converges? Now I got to do a whole nother test on the positive series. Okay, so my benchmark, and this one's maybe a little tricky. I'm going to do 1 over 3n. I don't know if I'm going to have enough room. Okay, so it's good practice. What was the comparison test? Oh, I need a benchmark? Okay. All right, so this guy, okay, this is good practice though. This guy is what? This guy is a P series or specifically harmonic? This is harmonic, harmonic, and harmonic always diverges. Okay, so if my benchmark diverges, this should be 3 ln 3n, 1 over 3n. This has to be true. It has to be greater than. So I have to check, is this greater than this? So this would be like 1/6. This would be 1 over ln of 6. So grab a calculator. Let's see, is that true? Okay, so can you see this even? Actually, 1/6 is this is 0.166, we know that. Okay, so this is 1 divided by ln of 6. This is 0.558. Ooh, we could do another one if we wanted, but I think we would see that this is always bigger. So the comparison test, if this diverges and this holds true, then this guy diverges. Okay, so what does that mean? Where's my... As an alternating series, it was convergent. As a positive series, it was divergent. Alternating series was convergent. That's what we proved up here. Positive series was divergent. So this one is the overall problem, the original problem is conditionally convergent. What are the conditions? It's kind of weird. The conditions are it has to be alternating in order to converge. If it's not alternating, it actually diverges. That is officially crazy. Okay. All right. So those are hard. When you have to use the alternating series, and if it diverges, you're done. If you have to use the alternating series and it converges, then you've got to perform a whole nother test on the positive series. We'll do one more like that. So let's keep cruising here. So we'll do one more like that, because it is a little crazy. All right, we did those, we did those. All right, let's do this guy. All right, the summation from n equals 0 to infinity, we're doing -10 to the n over n factorial. Okay. All right, a little hint. When you see factorial, you're doing ratio test. It pretty much always holds true, so that's kind of nice. One time where you don't have to think. So anticipate that like being on the test, because it's kind of a nice one that it always leads you down the right path. So factorial, ratio test. Now, do we know what a factorial is? Don't forget, like, is 6 factorial is 6 times 5 times 4 times 3 times 2. Oh, what am I doing? Times 2 times 1. I'm gonna see if, because this is shaking a little bit. Maybe I have to tighten this. All right, let's see if that helps. Because I see my camera shaking. Nah, maybe not. All right, so this is time. So should we do one more? Let's do, actually, let's do this. Let's do 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. So we're going to see this a little bit. Notice when you have a number and one bigger, okay, what's the only thing, if you're dividing, if we happen to be dividing, what's the only thing standing? The only thing standing is that bigger number. Okay, we're going to see that in just a minute because we're going to be doing the ratio test, right? The ratio test involves dividing. So that was a good review of factorial, and it's also a good review of the bigger number is the one left standing. And notice everything else goes away. All right, so factorial means we're basically going to do ratio test. What is that ratio test? Let's go back to that. The limit as n approaches infinity, we take the absolute value of, and remember you do n plus 1. And so this is going to be n plus 1 and then the factorial divided by, and then just the n. All right, and remember what you can do right away, the limit, it might help to write it out anyways. We're going to write the top, and remember now we're going to write this. We're going to write this as -10 to the n times a -10 technically to the 1 over n plus 1 factorial, and then times the reciprocal, n factorial over negative 10 to the n. Okay, let's see where that gives us. How are we doing? Can we see this? Hopefully we can. Yeah, okay, I think we can see it. All right. That would probably be helpful, right, as this is the only way you're learning this. Okay. All right, so what happens here? Not much cancels, but it is actually enough. This cancels for sure, right? And then what else? Here, it's actually the reverse of this, right? Think of this, if this would actually be like 5 factorial, and then this would actually be, if I plug in a 5, this would actually be like the 6 factorial. And so this last piece, this extra number, this n plus 1, is the only thing remaining. So, okay, so let's clean this up. We got the limit as n approaches infinity. So this guy would stay, the absolute value, this would be negative 10, and then these cancel except that last number, and that last number is n plus 1. So the only thing left standing is n plus 1. These two cancel, but that extra number, this n plus 1, is like the 6. Okay. All right, what are we doing? We're doing the ratio test. Okay, so you know, we could apply this. This would make it positive. We could put it on the outside, or we can leave it. N approaches infinity. We could change that to positive, right? And so it would be n plus 1. What happens? The bottom is going to get bigger and bigger and bigger, so the overall limit is 0. Okay, let's look up our ratio test. As long as it's less than 1, okay, 0 is okay. Remember, we're taking the absolute value, so we're not really going to come across negatives. But as long as it's less than 1, which would be 0, then it is absolutely convergent. Okay. Absolutely convergent. And remember, that's the nice thing. The nice thing about the ratio test is you don't have to do 2 tests. We know it's absolutely convergent. Okay. All right, let's do another one. Oh, what was this? We got a number. This was officially 5, right? We was talking about, or no, was that 5? No, this is 6. This is 6. Oh my goodness. All right. Who's ready for the end of the semester? All right. So that is 6. Okay, so that's good though. That means we're cruising, right? Yeah, that's 6. Okay. All right. So let's do 7, right? That would be the next. That would make the most sense. All right, for some reason they changed the letters on us. K equals 1 to infinity. If you want to take it back to n, that is more than fine. 2/3 to the k. All right. Well, actually, as I say, I like my ratio test, but how come here I have to do the ratio test? This is not an alternating series. Okay, this is not an alternating series. Now, could I use, like, where's my other list of tests? I mean, I could try to see if it fits a geometric series, a p-series, a comparison test. These are not out of the question. But I think this one, we pretty much do have to do the ratio test. Okay, that's where it's going to get a little bit harder, is when we start to bring those tests back in. All right. We'll worry about that at a later time, right? Okay, so let's do the ratio test. The limit as, now it's k technically. If you want to change it all back to n, that's fine. All right, so this is going to look a little crazy. We got to do k plus 1, and then we have to do 2/3 to the k plus 1 over, let's see, are we good enough? Yeah, so we plugged in our plus 1, and then we're going to do it over k to the 2/3 to the k. So here we don't really have to multiply by the reciprocal. This is one where, because we didn't have we just kind of had this fraction to begin with. What else do we want to do? Remember, we might want to take the time, maybe we should have written it since we didn't have to really multiply by the reciprocal. This is 2/3 to the k, and then times 2/3 to the first. Okay, and then we still have our bottom. Okay, and so this cancels out nicely. Okay, And so now we technically have 2/3, and then we've got a k plus 1 over k. This 3 can drop into the bottom. So we could write this as 2k plus 1 over 3k. Those two are saying the same thing. And then we could, if we wanted to, distribute that too. Now let's talk about why. Can we see? Okay. Don't forget we're taking the limit as k approaches infinity. Right? Let's see what happens here. Okay, so now we can do L'Hopital's rule. We could divide everything by k, or because they're both to the first, our limit is always going to be those lead coefficients. Okay. And what does, where did I put that? The ratio test. We use it all the time. I don't know why it's so hard to find. The ratio test says as long as my limit is less than 1, it is absolutely convergent. Okay, so less than 1, absolutely convergent. All right, we're cruising. Okay, good. Let's, yeah, so this one kind of gave it away. This one gave it away. I didn't want to use the alternating series test. But I had to be careful because, you know, could I have used other tests? Okay. All right. Let me come back to that one too, because there's another test. This one here, let's take a look at this one. This is 8. How are we doing on time? Okay. The summation, n equals 1 to infinity, n factorial, people, and then 100 to the n. Okay. It's not alternating. I see an n factorial. I see a factorial. As soon as I see a factorial, I'm thinking ratio test. Okay. So kind of keep that in mind. When you see that factorial, you're definitely thinking ratio test. Okay. All right. So ratio test says what? The limit as n approaches infinity of n plus 1 factorial over 100 n plus 1 divided by, and technically absolute value, but we don't, it's not alternating, so I don't think we're going to have to worry about that, n factorial over 100 n. Okay, slide this just a little. Okay, so this is the limit as n approaches infinity. The top is going to stay n plus 1 factorial over, we're going to write this as 100n times 100, and then we're going to flip over the bottom, 100n over n factorial. Okay. These cancel, and how do these cancel? Remember, this would be 5, 4, 3, 2, 1. This would be 6, 5, 4, 3, 2, 1, and we're multiplying. So those cancel, and the only thing left is that extra number. I'll write it in red. So this would be n plus 1. Okay. So we've got the limit as n approaches infinity, and this is what's left on top, n plus 1, and on the bottom we're left with just 100. Yeah, okay. Okay, that works. Good. Okay, so now what happens here? The top is just going to get bigger and bigger and bigger. So this is headed towards infinity. Okay. And if we notice, we said if the limit is greater than 1 or if the limit equals infinity. Now, obviously, infinity is definitely greater than 1. We don't really think of infinity as a number, so we technically don't, you know, like we have to write it separate. At least books have to write it separate. But yeah, anything bigger than 1 and infinity is definitely there. It diverges. Okay. All right. So that is that guy. Let's save those two. All right, let's take a look at this one. We got 3 more. 3 more. So this is, where are we, 9, 10, 11, that would be 3 more, right? All right, let's take a look at the summation as n goes to 0 to infinity, -1 to the n over 5n plus 1. Okay, so what I did here is I did for you, because the question, okay, let's pause for it. What's the question? This is an alternating series. Do I do the ratio test or do I do the alternating series test? Okay, that's kind of our question. And I usually like, which one do I actually like? I usually like the ratio test better, but I did the ratio test already just to show you that sometimes both paths will work, sometimes it leads you down the wrong path. All right, so this one here, I did the ratio test. You could kind of walk yourself through it. This here, I have to put in an n+1 right here. So I still have this +1. I distributed the 5, so I actually had 5n+5, and then I had this other +1, which took us to here. These would cancel, right? The absolute value, you know, I technically I don't have to worry about that because we take the absolute value. Okay, so I'm left with this. Really, I kind of like took the absolute value, so to speak, because I changed that to positive. But it's the lead coefficients, which is 5/5, which is 1. And if we do the ratio test, and it equals 1, we've got no clue what's going on. Okay, so every once in a while, it's just not going to work. So if the ratio test doesn't work for this, what do I have for an option? Well, because it's alternating, I'm going to use the alternating series test. Alternating series test. Okay, series test. Okay, so what is the alternating series test? I says what? My n+1. No, how do I like to write it like this. It has to be bigger than my n+1. It has to be getting smaller. It has to be getting smaller. And let's pause for a second. What is my b sub n? I ignore this guy, so I'll write this off to the side. And so I only have to focus in on this. Okay, so the alternating series test, I'm just going to focus in on that. I could actually start at 0 if I wanted. So we could let's plug in when n is 0, I get 1. When n is 1, I get what, 1/6. When n is 2, I get 1/11. When n is 3, it's actually going down right at 1/16. All right, so we can see that 6, 10, 11. Okay, yep, I don't know why that didn't look right, but go figure. Okay, so we can definitely see that it is getting smaller. Those fractions are getting smaller. If you want to put it in as a decimal, you could do that. Okay, so let's double check. Remember, if we're hesitant at all, 2 pretty much clears everything up. The limit as n approaches infinity, and I just do it like this. Okay, sure enough, as the bottom is getting bigger and bigger, I put in bigger numbers. The bottom gets bigger, which is headed towards 0. Okay, so the alternating series both work. Okay, all right, so what does that tell us? It tells us it converges. But is it absolutely or is it conditionally? This is the alternating. This is the alternating. We know that the alternating series converges. Now I have to do another test on just the positive series to see if that is convergent or divergent. So now, so that's kind of like part 1. Now I have to take a look at this. N equals 0 to infinity of 1/5n+1. Okay, I have to know this is the positive series. This is just the positive series. To test for, I'll put a dash because it's still together. Okay. All right, so let's see. So the first thing I did is I said, okay, let's do the comparison test. All right, so I said, oh, actually, so I said here, I just rewrote it. All right, And I want to take you down like some paths where it failed. So I said, okay, the easiest one is the test for divergence. It equals 0, so that fails. So I said, okay, the next one that I usually do then is the comparison test. So I picked out my benchmark. It's harmonic. It diverges, which means this situation has to be true. But this is actually smaller. This fails. This is not true, right? This would be like if I put in a 2, this would be 1/10, and this would be 1/11. So that fails. That does not work. So I have to go to my limit comparison test. So this one failed in a lot of situations, all right? It failed with the ratio test, and now it failed when I was doing the positive series. It failed with the comparison test. So now we're going to do the limit comparison test. I'm still going to use my benchmark. Remember, if I would have done the other, I could have still used my benchmark as this guy. This is harmonic, right? Harmonic. So it diverges. Okay. And so now, I don't know if I have, let me see if I have the limit. Do I have the limit test? Probably somewhere. Here it is. Remember, if my number that I get for my limit is greater than or equal to 0, then they either both diverge or they either both converge or diverge. And I already know that my first one diverges, so they're either going to both diverge or converge as long as I get, when I do the limit comparison, as long as I get a positive number. Okay, so let's do the limit as n approaches infinity of, and I put, you can actually go either way. I can't remember. We do this one. 1 over 5n plus 1 over my benchmark 1 over 5n. Okay, how are we doing space-wise? Okay, we're almost done. The limit as n approaches infinity. We're going to flip this over. So this is going to be 1 over 5n plus 1 times 5n over 1. Okay, so make sure we have enough room. The limit as n approaches infinity of 5n over 5n plus 1. Okay, if I'm taking this limit, L'Hopital's rule, divide everything by n, or if the exponents are the same, it's the lead coefficients. So it's 5 over 5, which is equal to 1. As long as it's greater than 0, they either both diverge or converge. And I knew that this one diverges, therefore this one diverges. Okay, so what is that telling me? The alternating series converged, but the positive series diverged. Where is that lovely piece of paper? What does that tell us? If the alternating converges, but my positive diverges, alternating converges, positive diverges, conditionally, can we see this? Yes, conditionally convergent. And we say it is conditionally convergent because under these conditions with the -1, it converges. If it's positive, it actually diverges. Okay, we're out of time, so I'm going to do a part C on this. And this will be a 2-day assignment. Okay, so just for time's sake, I'm going to do a 1/3 part. We only have two more examples left, so it'll go quick. Shall I leave that there?